whether it makes sense.
Yeah.
Okay.
Okay, well, I did get permission, so sorry to interrupt. Sound like interesting discussions, but so my name is Dave, KV0S, and this is the TAPR-HamSCI technical session. This week, Michael has been helping me move my K9Q Whisper Demon radio to a different computer, and it seems to be working mostly. Little configuration issues. And that's about it for me. So next on the list is Dave, KD0EAG. Go ahead, Dave.
Well, not a lot of excitement here. I wanted to tell Franco about that email I got, which I've now forwarded to him. But I have been working on schematics, various ones, magnetometer, the Clementine ones I was working on, I continue to fool around with, and so on and so forth. But I get into that, and it's kind of an obsessive thing. So, but that's been my last few days. That's all.
Okay. Next on the list is Bob, N5BRG. Go ahead, Bob.
Okay, hello everybody. I haven't got a lot to report either. I'm fiddling around with trying to do graphics and collect data, keeping the different experiments running. There was supposed to be a lot of sun activity today. I got an email indicating that, so I'm trying to look at my data to see if I can see some of that activity. But anyway, that's all I've got right now. Back to you.
Okay. Next on the list is Franco, K4VZ. Go ahead, Franco.
Yes, thanks, Dave. Thanks, Dave. Good evening, everyone. We spent some time, I think it was Tuesday or Wednesday, talking with Dave Witten and Tom here about the perspective of this new FX10 chip that which runs a super speed plus, which means fill at 10 gigabit per second, so twice as fast as the super speed of FX3. And we were looking at the specs. Again, very little is known, but from the specs, this CMIC can be operated in differential LVDS mode, which would allow us to achieve the best performance. We were wondering, and this again, a discussion is going on for the new HF24 project with Tom, if we may need to use an FPGA or not. So discussion going on. That's pretty much my my information here, my update here, and then from the Phil Harman DFC prototype, we found out that there is a resistor that should be a short instead of is an open circuit. So I'm gonna have someone try to put a drop of pin between the two 0402 contacts. I don't know if you have an idea of the size of that thing.
Oh.
It's like tiny, tiny, tiny.
Well, very good. Is that it?
Back to you, sorry. Yeah.
Okay. So next on the list is David McGaw, N1HEC. Go ahead, David.
Hello, everyone on the net. Been kind of interesting geomagnetically. Lots of flares and CMEs and whatnot. And as I sent an email earlier today, 25 megahertz WWV has been behaving very oddly. Coming in at night, not coming in during the day, that sort of stuff. I signed up for the virtual version of Cedar, so I've been kibitzing on there the last couple of days. In some ways, I think my head's going to explode, but they're having some very intense introductory talks. But unfortunately, virtually, you can't get in on any of the workshops, which is where the real stuff is. But I know Nathaniel and Christina and a whole bunch of other people are in on that. So, yeah, I'm finding it very interesting getting up on all the different aspects of what's going on between with the ionosphere and interactions thereof. A lot more complicated than one might think. Certainly not if one were just a ham trying to bounce radio waves off of it. But anyway, I think that's about it for here. So back to Nat.
Okay. Next on the list, let's see, it'd be Jim, K4BSE. Go ahead, Jim. Mike.
Probably help if I mute that, wouldn't it? Well, good evening, everyone. Not a whole lot to report here. I finally got my RX 888 working the other day. For some reason, the control software I tried to use the first time was not working. So I tried another control software program and it worked. So I don't know what the story is there. Thought I followed the instructions on installing the first one properly, and I could control the radio with it, but couldn't get any sound out of it. Second one, everything works fine. Otherwise, not a whole lot ham radio to report. Back to Nick, K4BSE.
Okay. Next on the list is Joe, KW7LUX. Go ahead, Joe. There.
Thank you, Dave, and good evening, everyone. Let's see, I've been sitting here monitoring, and just like David threw out, my two receivers are bouncing up and down as various solar flares and whatever's hit the ionosphere and cause all sorts of problems. And Phil, yes, I did send comments into the FCC on what I saw here during that eclipse, not the eclipse, but the CME. To be more specific, the two races nets that are on Saturday and Sunday mornings here in Arizona were very strongly degraded. And stand by. And we had trouble hearing the weaker stations. Anyone who didn't have a full-size antenna at a reasonable height was basically left out of the conversation. And of course, what we did on the Sunday morning net was move up to 40 meters from 75. So that's what's happened here, and that's what I told the people at the FCC. TAPR, I hear rumors they're going to be coming out with a GPS discipline oscillator. Does anybody know anything about it, or when it might be available, or anything like that? And back to you, Dave. Thank you.
Oh, okay. The plan is John Ackerman is working on such a thing. When it'll get done, I am not sure. And
so I might have to order yet another Leo Bodnar. I've got two of those things, and they're both tied up running radios, and I need a third one for the 888 and also for my ICOM 9700, which uses one of those to lock its frequency.
Right. So I can't give you any better than that. They are in the works, but John has been bogged down by several projects all at once, and I think he has some back and forth making trial versions and then testing them and then finding something he wants to change.
John's a very busy person.
Yep.
So,
Did he say? Go ahead, Dave.
The alternative is to use a small distribution unit, so which are available from TAPR and from SV1AFN and other sources besides those.
Understand. Thank you.
Sure.
But I'll just point out that John was on a week ago talking about this, if you're interested in going back and looking at that.
How does one do that? How does one go back and look at the older
You
recording.
go to HamSCI website, and right at the bottom of the header, it has a link to the recordings of all the sessions, and you're looking for this one.
They're
Yeah.
on YouTube, right?
Yes, they are on YouTube. But I always find that going to HamSCI first was the easiest way to find them.
Okay, thanks, everyone.
So anyway, I got to get back to participant. Next on the list, got Joe, be Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. Nathaniel, as others have mentioned, he's at CETA right now. He was speaking to a researcher from the Space Science Institute and Christina regarding another research project, particularly satellite observations in tandem with ground-based observations, including VLF receivers. And so that's actually pretty exciting. I've worked on the block diagrams of the new VLF reception system, at least the back end, including the GPS interface box. I just wanted to share this quick. This is the 3-channel version of the VLF reception system. It includes the Dell-Wise 5070 thin client, and instead of the Behringer UMC 202, I used a Behringer UMC 404 HD, which is the 4-channel version. I actually have one of these. I don't have the 202. The intent is to replace the Raspberry Pi system right now that's running at Nathaniel's with the Dell-Wise thin client and the UMC 404 HD, which then that will allow me to have 3 channels. So the 3 channels is the VLF-E field, the north-south B field, and the east-west B field, from a north-south, east-west orthogonal loops and preamp that'll be installed outside. So once this gets rolling, the volunteers and whoever is interested can also install the north, south, and east, west VLF loops, which will give directionality, and it also gives a new another insight to VLF signals. It's actually pretty cool to see signals captured on orthogonal loops, especially in VLF, but also radio in general. So this is the three-channel system, and it of course uses the GPS box, the GPS interface box. That was the other thing that I wanted to share quick. The GPS interface box is specifically an interface box for the VLF system, and there's not really much to it. So it's a GNSS timing receiver, and so what it is, the box is going to contain a board. The board, the way that I'm envisioning it, it'll be compatible with multiple different GNSS module footprints, The only signals that I'm interested in are the PPS output, of course, and the UART. So that's why we could accommodate a different footprints, the Trimble Res 720, the older resolution series, the Think Fat U Blocks breakout board, and lastly the ugly carrier breakout board that John Ackerman has been working on. I was thinking that would be a really good option to have, because since John intends to sell those for people to actually use at the TAPR store. I also intend for this to be sold at the TAPR store, but this is specific to the VLF system. So the outputs are the pulse per second, and it'll go through an adjustable voltage divider, a pulse output selector that'll be with jumpers and pin receptacles for RC networks and capacitors, either a regular standard pulse train, an RC shaped pulse or a C shaped pulse, LED indicators, and an RS-232 transceiver. And the RS-232 signal will have the pulse per second on the data carrier detect line, which then will be used by the thin client to bring the pulse per second into the thin client in a very low latency manner. That's why we don't use USB here. And it allows GPS daemon and NTP to run and discipline the clock as insurance. If something goes wrong with the PPS output into the sound card, the VLF-RX tools can still rely on NTP to maintain some reliable timing. A challenge that I found was with transmit and receive indicators, LED indicators. You need to have some sort of circuit to shape the pulses to a pulse width that's visible and like actually makes sense as a transmit and receive indicator. I'm still trying to figure out what would work best. And I was thinking, and John Ackerman recommended a monostable multivibrator and a pulse shaping circuit, and that should be pretty effective in indicating traffic, which is what I want to do. So for the user, this will so the user can actually see that there's UART traffic, and then there's a pulse per second LED, and they know that this is working. So that's why they want to have these LED indicators on here to aid in any sort of issues or problems, and to let the user know that everything's working well. Lastly, in other news, the author of VLF-RX tools, he will be relocating his VLF receiver to an even more radio quiet location. So I'm actually quite excited as to what VLF advancements are coming, because he contributed quite a bit to the VLF community. That's all I have. Back to the net.
Okay, very good.
If I could for a moment, Jonathan, do you know who Nathaniel and Christine are talking to? Jonathan?
Mike Hardinger from the space
I
side.
think he's involved with the project I'm on. Thank you.
Cinema, movie?
Yes, that's
Yes.
the project I'm on.
Oh, okay. Yep. He's interested in a network of VLF receivers. So yeah, that
And a whole bunch more.
yes. Yeah, he's drafting up a proposal now.
Yeah, Robin Millen, who I'm working for, is on that project.
Oh, okay. All right, good.
So,
Yep.
okay, thank you.
We'll continue with the roll call. Next on the list is Michael, AC0G. Go ahead, Michael.
Good evening, everybody. Excuse me. I've been working with Rob on some Whisper Demon stuff. Apparently, some of the decoders that he was using in binary form from either standard APT install into Ubuntu or others weren't quite as efficient and burning some excess CPU time on machines that were of marginal speed or power. So I built some versions of Whisper Demon and JT9 from the source code of WSJTX, and for whatever reason, it has nothing to do with me. I just hit the make, type the make command, and figured out how to get it to run. They run quicker. So that's a considerable advantage to some sites that have been pushing the envelope on the capacity of their machines to handle some of the things that they might want to do. The patch that improves the spreading analysis built in with the same basic source code also works quicker. So that's one thing I spent some time doing. I'm also trying to make sure I understand how to integrate some of the information we get from satellites. Dave Witten loaned me it's not the latest generation of SparkFun GPS receiver, but it's a step up from the ones that I had, the ZFP9, and I'm having a little bit of fun playing with that. And looking forward to going up next week to Minneapolis and celebrating my mother's 90th birthday. So one of the things I've been working on all week is collecting some old photographs and home movies and things like that and compiling them into a little display that we can have. It looks like there's a whole ton of people who are going to be able to come, which is going to be really great. Back to Ned.
Very good. Next on the list is Phil, K9Q. Any comments?
Hey, Dave. Not much more than what I said before. I'm still shaking off a nasty flu. At least I think it's a flu. The COVID test was negative. So I haven't really been doing a lot of work much on anything lately. I do have a couple questions for let's see, Jonathan and Dave later, but I guess we can hold off.
Okay. And next on the list is Scott Newell. I don't know. He usually doesn't have a mic. Is that still true, Scott?
Yeah, he just messaged that he
Oh,
doesn't have mic tonight.
Yeah. Okay. And then we have Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave, everyone in the group. Been working on the requirements document for the new receiver. And as Franco mentioned, we had a conference call, cleared up a few things. I revised the document and defined two kinds of clocks, class 1, which is a low cost, class 2, which is a high performance, and then sent that information to John Ackerman for review. And John reviewed it and indicated what he thought might be some good cost objectives and parameter values. So all that's been folded into version 0.3 of the document, which is up on Nathaniel's document site. I don't have a link to it, but Nathaniel posted a link last week on how to get to that document. If anyone needs a copy, let me know and I'll get you a copy of it. It's still in process, but it's getting a little bit cleaner as it goes. And Bob, did you survive all that bad weather a couple weeks ago?
Yeah, sure did. There was a tornado about a mile south of me, but it was nip and tuck here, but no problems.
Oh, glad to hear that. Glad to hear that. And back to the group.
Okay, well, that brings us to the end of the list. I think I've called on everybody. So we're open for general discussion.
Jonathan, I had some questions. I've never been interested in running your stuff because I've assumed I have a crappy location. I'm in Southern California. The lot is small. I'm near some power lines. The soil conductivity is low. I mean, is that a valid assumption, or are you looking for as many receivers as you can get?
Well, one can be, I guess, pessimistic, but it could turn out that so basically you want to make sure that your hum levels, including all those nasty power line harmonics, don't overload your sound card. And as long as they don't, and they don't overload anything else in the chain. So if you have isolation transformers and, your gain stages, as long as nothing else is overloaded where it's generating even more harmonics, it is possible that some of that power line hum can be filtered to a point where it's actually listenable and usable. And it also depends on like if they're if the power lines are very high voltage, upwards of 1,500 kilovolts, they're going to have some current running through them, so they would radiate quite a bit. But the best way to tell is to fashion yourself some sort of VLF receiver. One of the simplest ways is to get a portable audio amplifier. Radio Shack sold one years ago, and get a couple loops of wire and make a nice loop, connect it to the audio amp and see what you get. As if you could hear spherics pretty well, and you could get your hum levels to a point where you could hear the spherics well, it's definitely worth a shot. And then from there you could investigate further and run your samples through filtering, and see if you could get something pretty usable. So if you're interested, we could definitely work together, and maybe we could get something running.
It's one of those things where, I mean, I want to know that I have a high enough chance of success that it makes it worth even investigating. I don't know. I mean, I feel like I'm in a really disadvantaged area for that.
Are you in, I guess, what you would call the suburbs?
Yeah, well, I'm the city of San Diego, but most people would call it the suburbs, and I'm near two 237 kilovolt SDG&E power lines to carry much of the power south into San Diego. So, actually, I'm surprised I don't have more trouble from them than I do. Most of my problem is from switching power supplies.
How bad are is your reception on high frequencies? How much
High
noise do you have on high
frequencies
frequencies?
is better. I mean, it certainly doesn't compete with KFS or KPH, but I mean, I can certainly hear you know, what most people hear on HF. But, you know,
Yeah,
it's all
don't
about
hear-
background
If you don't hear a lot of pulse noise, you're probably okay.
pulse noise. Well, actually, I kind of do, actually.
Well, you know, like, yeah, power line pulse noise.
Yeah, I think I probably do. I wonder,
If you
would it help?
take an AM radio and tune it to a open channel and
Yeah.
wave it around, see what you get.
Yeah, you do that. One question I have was, would it matter? Would it be advantageous in any way to have an input reference to your receiver come from the local power line? So you get the phase and exact frequency of the local 60 hertz supply.
Yeah, well, the problem is that you're gonna get a bunch of other signals from elsewhere, and it might not be that effective of a filter to kind of cancel everything out.
Well, it would give you the exact frequency because the power line is only nominally 60 hertz. It does vary, and I don't know how narrow the filters you're using are. This would give you the exact frequency and phase of the power line, although actually you need to use 3 of them. I mean, I only have single phase power in my house, but I'd be picking up noise from all 3 phases.
Well, the so the mains hum filter includes an integrated tracking filter. So it locates the fundamental and the harmonics, and it tracks their frequencies throughout the day.
Okay, so it will track small variations in power
Yes.
line.
Mm-hmm. Yeah.
And if that frequency would drop suddenly, you could flash a warning and say your power's about to go off.
Yeah. Yeah. Actually, you know, with a VLF receiver and VLF-RX tools, you can have a pretty effective power monitor, and then you can do a lot of signal processing with it. So even if you can't do VLF, you could still do a lot of interesting things with power monitoring too. So I mean, you know, what I would do is I would look for a location that's like the furthest away from anything with any sort of power lines, and I would start there. And if you could fashion up a quick and dirty VLF receiver, which is usually pretty effective, if you could hear spherics, then there might be hope.
Yeah, it sounds like I'd have to find a friend with a good lot. I mean, my lot just isn't it.
Yeah, that's because distance is the enemy here, and if you don't, if your lot is too small, then you're not going to get those distances, and
yeah,
obviously, but
it's Southern California. Look, I mean, you know, my
Yeah.
house is my house is only worth about $1 million. It's not that big.
Unless there's a bad insulator somewhere nearby, the power line is usually not the problem. It's all those switching power
I'm
supplies.
afraid I am seeing that. I do see what appears to be a lot of broadband hash at 60 hertz. So that tells me that I probably am seeing discharge. I mean, I should probably watch this through the next big rainstorm.
Yep.
And
And by the way, the power company is required to fix that if you can narrow it down. They won't narrow it down, but they will listen to us.
Yeah, I mean, I think SCG&E got rid of their power line interference group when their last guy retired. But I guess if you hand it to them on a silver platter, then they might do something.
Well, they are required by the FCC to keep their lines clean, but they
Yeah,
don't
well,
really have the expertise to track it down. But like here in New England, we actually have set up an RFI sniffing team under ARES
yeah.
and ARRL. You may have the same in your area that you could contact and have them check
Yeah,
out whether it's
The thing is, the FCC requires lots of things. Whether they actually get done is, you know, different
well,
story.
no, my point being that, and my partner actually works for the power company, so I know this as a fact. They will respond if you give them good evidence.
I guess if you point out that, first of all, they're wasting their product that they're trying to sell for money, because this is all happening before the meter. And second of all, it could be a serious safety problem. I mean, insulators that are arcing could be, dangerous.
Yeah, but it's also RF in that, remember,
Yeah.
aircraft have AM radios,
That's right.
and arcing insulators will put out hash all the way up
And
through
right off
VHF,
the end of a
UHF.
runway of an airport too, military airport.
So,
But
no, they are.
actually, I was thinking
are
in terms of
responsive.
PG&E, going bankrupt because one of their lines started a fire not long ago because it was badly maintained.
Yeah, there's that too. You
Yeah.
have an additional hook there.
Yeah.
What we start with around here is ask people to shut off all the power to their house while they're monitoring a battery powered receiver.
Yeah.
And
Yeah.
usually finds a whole bunch of stuff. And the previous suggestion about a little AM radio with a loop stick in it, go around and poke it near these wall warts. And then you could buy a whole bunch of toroids from a guy out in California, Palomar Engineers or something like
Yeah.
that, to wrap around the cords coming from these wall warts.
Yeah.
Boy, oh, that really
I've have a bunch of several large boxes of Palomar toroids, and I've attended this guy because he's a local. I've attended his talks, and my experience is that they don't really help a whole lot. I mean, they might make a marginal difference, but what really helps is just finding the offending device and exterminating it. Replacing it with
Yes.
something else.
So you have to be careful too, because ferrite is not all the same, and
That's true. That's true.
it's it all depends on what band you're trying to knock down, and
Yeah.
there are ferrites that will knock down into the AM band and below. I've used those because we do
Well, I'll
via
give you an example of what I
research.
mean. I mean, the noise can very often get coupled in very unexpected, strange ways.
yes.
Yes.
I discovered I have two access points made by Ubiquity, and they have very noisy DC-DC power supplies. They're PoE power, so they have 48 volt to whatever switching power supplies, and they produce really nasty spikes in about 80 meter band, around 44 megahertz. And I started wrapping cores around the wires. I tried to put as many turns through them as I could. I tried, moving things around, and nothing really helped until I went to the switch that they were plugged into and started unplugging unused drops. And then suddenly the noise went way down, and I realized what was going on. The noise is not being radiated from the wire. It was being conducted back to the switch and then radiated out through the unused wires. It's unexpected things like that you got to really think about. It could very well be coming from something you totally didn't expect.
Yep. Anything can be an antenna.
That's right.
I've had really good luck putting those ferrite toroids on the power supplies for the grape receivers. Really knocks down the my high frequency noise.
Yeah. If it's common mode, it probably would. In this case, I think it was differential mode. And in case they would not help, right?
Well, no, it's going to be common mode in some form because, especially in two wire cords, twisted pair cords, differential
Yeah.
mode's being nulled out.
In theory, yeah, and in twisted pair it would, but I think what happened in the case of my access point was the reason it didn't help was because first of all, it wasn't being radiated from there. Second of all, what was going down was differential mode. The switching power supplies produce a lot of differential noise, but
Yeah.
it was getting converted into common mode radiation when it went out this terminated cable.
Yeah, exactly.
So,
Yeah, we had a big problem with that with a repeater that we had that shared a tower with a wireless access point, and it had an Ethernet cable going up past it, past our antenna, and we were getting tremendous radiation off of that and it was the router down at the base of the antenna
yeah.
that was causing it. And ferrites did help it, kept it from going up the tower.
Yeah, well, the moral is, don't assume too quickly that you know where the problem has to be. It could be
That's
anywhere,
right.
pull anything out. I mean, I keep learning that lesson over and over again when I try to, find RFI. I keep learning that again for some reason.
Yeah, there are some instances when all else fails, plug it in. In this case, unplug it.
Unplug it, yeah. Well, my problem is my receiver depends on a large computer, which I can't turn off. I mean, it's an SDR, it requires a
Right,
PC.
right. Well,
That's
the interesting thing is PCs tend to be very quiet because they have to meet FCC.
Well, not in my experience. I mean, PC that I
Maybe they've gotten worse, but in the early days, certainly, they had to get past FCC, they had to accommodate anything and everything that could be plugged into it. So they
Yeah,
had to make them very quiet, as opposed to Macintoshes, which tended to be very noisy because they knew they had a very limited number of things that they would have plugged into them. So
yeah.
they would meet it just barely.
Yeah, but I have this, 100-watt transmitter running inside my PC that's transmitting at 75 kilohertz at all the time, right?
Well,
And
now
it's
there's an
huge.
interesting point. The power supplies are widely variable, and I have found this, that there are those that have the proper EMI components in them, and there are those that don't.
Yeah,
And you may have
Remember
to swap out your power supply till you find one that's quiet.
yeah. I bought one that I thought was a good one not long ago, but
Yeah.
Class B doesn't mean zero interference, right? Class B just means
No,
Class B.
but it means has to be pretty tight.
Problem is we hams have more exacting standards than that, much more.
Yeah, one of the things I'm running into at work is that it's considered an industrial location, so they don't have to meet Class B, they only have to meet Class A.
Which is not as exacting, right?
And with fluorescent lights and LED lights and things like that, it's
Yeah.
noisy.
I have somewhere in my neighborhood close to me is a compact fluorescent bulb that goes on every night and goes off in the morning. And I know it has to be compact fluorescent because I see this band of harmonics every 20 kilohertz, which is, characteristic of compact fluorescent because they have a
Right.
inverter that drives the bulb at that frequency. And I have no idea how to find it. I mean, I can go around my neighborhood, I suppose, with a camera or something and just wait to see when it goes off or when it goes on. At first, I thought it was a Christmas light, but when it kept going after Christmas season, I knew that couldn't be it. So I guess I could just wait till the bulb burns out and they replace it with an LED.
Now, well, what band are you hearing this on?
I hear it typically across the 49-meter broadcast band and the 40-meter ham band.
Uh-huh.
I mean, affected by resonances. You can
Yeah,
see.
'cause we actually have there is such a thing as a terminated loop HF antenna, which is directional and can
Yeah,
be used to sniff things like that.
yeah,
I've trying to remember who makes it. I've got one, but it was supplied to us by the our RFI initiative.
yeah.
I think it's an DX engineering thing.
It's one of those
But
things
it's
where,
easy. You can make your own. It's easy. It's like,
yeah,
you know,
it's one
1
of those
meter
things.
loop with a resistor in a particular place.
It's one of those things where it's a nuisance, but it's not painful enough that it actually makes me go
Yeah.
out and, it's in between.
Right. Well, I suppose the good news is compact fluorescents eventually die.
That's right. That's right. And modern LEDs, actually, most of them are not that bad because the cheap design just uses a bunch of series LEDs with a capacitor as a current limiter. And that seems fairly, when I think about it, seems fairly inherently clean.
Yeah, I've had both.
I mean, I've seen some that go bad, but most of them seem fairly clean. But yeah, complex fluorescents are pretty bad.
Yeah, I always wondered about them. There's that nice little coil antenna called the plasma tube.
Yeah, yeah. Yeah, exactly. Although Glenn Omar said something that I saw, it's one of those things where it's obvious once somebody says it, but you didn't think about it before, and you don't know how you couldn't have thought it earlier. But when I started talking to him about interference at low frequencies, he says, forget radiation. Everything is ground loose because everything is too small to radiate at those frequencies. And I
There's
realized
that too.
that he's absolutely right. And so I got to start looking for ground loops.
Yep. Keep
Um,
cables bundled.
Yeah, well, also try to not just try to isolate ground. So I ended up buying uh, two distribution amplifiers from TAPR at Dayton, one for the GPS L1 frequency and another one for 10 megahertz coming out. Surprisingly, the GPS distribution amplifier helped, even though it does not have isolated grounds. I think just the reverse coupling from one device into another probably helped. Because one of the devices is a Kiwi SDR, and the other one was was my GPS DO, which is probably feeding a fair amount of 10 megahertz back through its antenna input. It was
I'm trying to remember what bandwidth John designed the HF distribution amp for, whether that would take the 27 megahertz through it. I know it does
well,
10.
it has an optional bandpass filter, but I think it's inherently broadband.
Right. But I don't remember what how high he designed it for, whether it would pass the 27
Yeah.
if someone wanted to use it for distribution amp.
My 10 megahertz stray problem is not completely gone, but it does seem to be better than it was. But I would not mind if everybody went to 27 megahertz, because who cares about 27 megahertz, right?
Right.
Yeah,
Are you
That's
talking about the
that's
TAD
CB and
one?
that's a CB frequency.
exactly. So who cares if it gets into
Middle
my
of the CB band. Screw 'em.
exactly. What were you saying, Mike?
Well, I built the TAD one. I'm using a Gus, which I got from Tapper to distribute the GPS receiver signal.
Right.
And then I'm using a TAD one after a Bodnar. And
Right.
the TAD one is capable of distributing a broad band of frequencies, including 27 megahertz.
Yeah,
And it's
that's what
got
I was
transformers.
asking. I just didn't remember if
Right.
he designed it for that high. But if
Right.
it works, it
And it's
works.
got
Oh yeah,
transformers,
he says
all input and
usable
output.
200 kilohertz to 30 megahertz. So yes, it absolutely will work.
Yeah. I mean, that's why I got it. Aside from a couple missing parts, I was able to find in my junk box. It works fine.
Oh, there was one thing that I wanted to mention, quick too. Regarding power line interference, and I have no idea why this is, but for whatever reason, during thunderstorms, I don't know why this is, but it seems like that power line emissions increase. Their amplitude will actually their signal strength, their magnitude will actually increase. So when you're listening to the VLF feed, you could hear 60 hertz hum much louder than you could when it wasn't thunderstorming. And
it probably has to do with the rain rather than the thunderstorm itself.
Well, I was going to ask, is it raining, or is it, at what point in a thunderstorm do you notice this, Jonathan?
I don't necessarily notice when it rains. If there's local lightning, and if it's like a heavy rain, but it could be the conductivity.
Yeah, it changes the ground conductivity.
Yeah, that very well could be it.
So any ground currents would be increased if it's raining.
Yeah, that's right. That's right. It would.
Yeah.
And depending on what part of the country, and there are different conventions on grounds.
That's
Yeah.
true.
Yeah, California is very different. California and Nevada, I think, are very different from the East. Out here, all transformers are fed phase to phase, like a delta
Right.
configuration. While in the East, they're fed in a Y configuration.
Right.
So, and I think the difference has to do with ground connectivity. Out here, you can't rely on it. So it would be unsafe to
Well,
return
yeah, well,
primary.
Y always has a ground wire running along through the pole as well.
That's correct. But what happens
Whereas
if
delta
ground
does
is
not
lost?
require an explicit ground.
That is correct. Okay. But now look what happens in a Y area like the East Coast. First of all, they have frequent grounds grounding that neutral wire because it is shared with the secondary of the transformers, right? And that's going into every house. Now imagine what happens if you lose the grounds out on the neutrals on the power poles.
Right.
What happens, right? It could be very dangerous to the houses. So out here, I have a feeling that the reason they do this is because you can't depend on it anyway. So they don't return primary currents through the neutrals. They return them through other primary phases, even though it means more wires and, more expensive transformers. I mean, that's standard practice here. One of the first things I noticed, I moved out here because, hey, I'm an electrical geek. I noticed stuff like that. But it has to do with soil connectivity. I can't imagine anything else.
That if you hear harmonics come up, there'll be insulators. But if you're just hearing the 60 hertz come up, that would be ground conductivity.
Well, it's everything. It's 60 hertz and harmonics.
Yeah.
And well, it's a strange problem because even like during like soaking rains, like if I were to get if the receiver site were to get a good soaking rain, the hum levels don't increase. It's always during a thunderstorm, and I'm completely baffled because the software I could actually monitor the amplitude levels of 60 hertz and other 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 uh, well, you know what I mean. And I could monitor those just like I could monitor VLF transmitters. So with 60 hertz, I monitor in a 2 hertz wide around 60 hertz, and I monitor 5 hertz wide around 180 hertz. And both of those will increase during local thunderstorms. And I could also hear it. But why that happens, I have no idea.
When the increases happen, is it sudden?
Yeah. So it's
maybe when line somewhere gets hit by lightning, because it happens all the time. They frequently get hit by lightning. Usually there's screen wires in the tops of transmission lines that are there for that reason.
Right. I don't really think it's. I don't know. Well, I don't know if it's because some transmission lines might get hit by lightning, but it's.
Well, what's the other between a thunderstorm and a rainstorm? It's lightning, right?
Yeah.
It's got to be ground conductivity from the water.
Well, but he just said that the heavy rains by themselves don't do it.
Yeah.
It's lightning. So that's the puzzle. And the only thing I can think of is that power lines are getting struck by lightning all the time in a thunderstorm.
Yeah, but how long does the increase happen, Jonathan?
So, the hum levels will actually increase during the thunderstorm, and as the thunderstorm finishes, they will decrease back to what they were.
Yeah, interesting. By the way, Scott just put in reminding us that Alex Anderson Day is coming up.
Yes, yes,
It is that he says next month, actually this month, it's June 30th.
right, right.
And it looks like they're doing 2 transmissions, which is nice of them.
Mm-hmm.
And he asks, is the USA just too far? It is not. There are people who have been known to receive it. I have not yet. I've tried, but
Your during the summer, it could be difficult because there's obviously increased lightning. So your VLF noise floor will actually increase.
yeah, well, I've got a spectrum analyzer I'm using to find it, and I can receive the naval stations fine. I just haven't. They're lower power, and I haven't been able to see it above the noise floor.
Well, there were times. So I remember Christmas of Christmas and Christmas of 2021 and 2022. I believe 2022 was canceled, and it was done at a later date. I was able to receive those just fine, but last Christmas, it wasn't copyable. Last summer, I could not copy it because there was I don't know if they're just not it's not they're not using a high enough power output, but I wasn't able to copy it. But Scott, it is absolutely worth it to give it a try, because you never know. The one of the good things about VLF-RX tool software is it includes a spheric blanker, and that was written specifically for amateur transmissions in the VLF band, and that actually helps quite a bit. And last summer, I was able to run the transmission, or the I was able to run it through a spheric blanker, and I was able to actually get when I did a power integration at 17.2 kilohertz, I was able to get a peak. Still wasn't able to copy it, but I was able to get a peak. So I was able to get some power. So it's definitely worth a shot.
Yeah, and one thing too to realize is if you send in a signal report, and that can include a null report that you did not receive it, they will send you a QSL card.
Yes. Mm-hmm. Yep. Any signal report, whether good or bad, you will get a QSL card back. Nathaniel and I, we got ours Christmas of 2021.
So anyway, just to finish the thought for Phil, I do recommend finding a portable AM radio. As I say, tune it to an unused station and wave it around. That's a very effective way of finding out what your noise
Yeah.
is.
Yeah, I just have to do it. It has to
You know,
reach
what's interesting is I'm finding it difficult to find radios that you can do
Yeah.
that with. Nowadays, the radios that they're selling are these wide open input SDRs, and between them being full input and them having defaulted, they have AGC and muting. They just don't behave like the old radio does.
Yeah, those SDRs are a fad.
I have an old AM radio that I used to use to identify where the ground wire was for the radio fence to contain my dogs.
Mm-hmm.
When I first moved into this house, they had some dogs and they'd installed one of these things, and I just kind of said, "Oh, that's cool. I'll use it too." But then, of course, something broke, and I had to try to figure out where the bloody wires were because they were all buried. And so I got an old-fashioned cheap old little transistor radio. Worked good to just kind of walk around and find the damn thing.
Yep. Unfortunately, that's how I would find cables out on the ice in Antarctica or like Greenland, whatever. Is the cable acts like an inside-out waveguide in the snow, and
Mm,
it conducts noise from the station out to the antenna field.
yeah, perfect.
And I actually made an HF sniffer that I could change bands on and whatnot to find noise sources. And but it was easy to find those cables.
Where were you in Antarctica, Dave?
South Pole.
Oh, wow. You're the second person now I know have been to the South Pole.
Yeah, South Pole and keep going 500 miles.
Huh.
We were we got some stuff at South Pole. We have had stuff out on the ice at the AGOs, Automatic Geophysical Observatories. They've been pretty much abandoned at this point, unfortunately, but this is like 10 years ago we were out servicing them.
I've always been fascinated by Antarctica, but man, I just don't like cold. I went to Cornell for 4 years. That was enough.
I love cold. I like to say I have cold weather genes.
Uh,
I've got Scottish heritage on one side and Polish/Scandinavian heritage on the other side, and I don't like it hot.
yeah, well, I mean,
I don't like being cold, but I definitely like cold air.
my health, they wouldn't let me within 10,000 kilometers of the place. That's the difference from the equator to the pole, by the way.
Right. By
By
definition.
By definition, the original definition, yeah.
I'm going to
Yeah,
sign
we've
off.
actually got stuff at South.
73.
We have stuff
You
at
might-
South Pole and on Baffin Island because they're magnetically conjugate.
What can you tell me about the darn radars? What pulses, what kind of waveforms they transmit?
I'm not sure what the pulse width is, but it's fairly short because they are trying to locate. I don't know if the pulses are like a kilometer long.
Well, I mean, do they must have a whole family of them. They probably don't just transmit one pulse, do they?
Well, yeah, they have pulse trains, but they are, by the way, specifically required to stay off of the ham bands.
Well, good for them.
And I'm not sure, it's a good question what their bandwidth is. But of course, their spatial resolution is dependent on the pulse bandwidth.
Yeah, right, of course.
Um,
I've been trying to interest Rob in looking at ocean radars. And
yes.
this,
Well, actually, I know people who use CODAR.
CODAR, yeah.
And
It's wider than anything we can generate, right? And it's there
right.
all the time.
The only
It doesn't
thing
use
is
up
that
mass back.
it's on the coast, but
Yeah.
Steve Kapler at Clemson uses that, and we should be talking to him about that.
Well, I live on the coast. I mean, I've seen one of those stations. They're not much to look at, really.
Right.
They're
Well,
just
I'm just saying that's useful, for those of us on the coast, but in
Yeah.
the midsection.
Yeah, I'm about 70 miles inland and you can see the backscatter off the ocean radar very strongly.
Oh, absolutely. But I'm talking the guys in Missouri might not be able to pick it up.
Yeah.
No.
But it does give an idea of the sort of waveforms that we could use.
Yeah. I've been meaning to look at this. I did dig up one of the patents for Codar, the original one, and I might be able to learn something about what waveform they use. It's not a straight chirp. It's pulse. There's a pulse sequence at each hop. It's actually hopped.
Right.
As you can tell, when you listen to it in the AM demodulator, it sounds very different.
Right.
So if we know what that is, or I could just go sit next to one and record a clean copy. And if it's the same as all of them used, then, we could do
Yeah.
something.
Yeah. Well, I don't think it's secret. And I know Steve Kepler uses that for the research. He was a grad student when I got to know him. He's at Clemson now.
Well, it's not secret.
He comes on our no, it's not a secret, I think. And he comes on our on these sometimes. Usually
Well,
the
I've been thinking
science.
about this because Rob wanted me to generate like a new whisper waveform that could be used for
Right.
play, right? And I'm thinking, well, wait a minute, why do we have to go all this effort if there's signals already on HF that we could use? There are a lot of
Yeah,
places.
so
maybe
as I
only on
say,
the coast, but
we'd
still.
like to probably come up with a scheme that we can deploy so that it has much wider it's much wider area, covers much wider area than Codar will.
Yeah. But
Michael,
Codar is all of HF, right?
Yeah, but the thing is, you're going to be getting it oblique propagation pretty much everywhere. Instead, you can't sound vertically unless you're right next to it. And
Well, aren't they transmitting with Omni whips? The ones I've seen anyway are just simple whip antennas.
well, I'm just saying that propagation is different near vertical versus oblique, and we'd like to know both.
Yeah, sure. But they transmit all the way from about what, 4 megahertz to 26, something like
Yeah,
that.
I need to look more into it, of course.
I mean, you certainly have no problem finding them at night. I mean, they're all over HF and they show up very distinctly on a waterfall.
Yeah. Well, then there are a lot of other signals of opportunity. The chirp sounders are available.
Well, I see them, but the ones I think they are, I mean, they're intermittent and I mean, I don't know what their transmission
Yeah.
sequence.
Well, some of them are explicitly sounders. Others are over the horizon radars and things like that.
Yeah. Well, the military
So
ones probably don't have much documentation for, but
yeah, but like Nathaniel has been working with chirp receivers, and you get to know what's there, and as long as it seems to have an actual tie to pulse per second,
yeah.
you can figure it out and use it.
Yeah. I think Bob McGuire's students built one, although I don't know the waveform.
Yeah, well, Juha Virnen, who's now at Tromsø, is the one who figured out how to do this.
In Norway?
Yeah, he's in Norway now. He was at MIT when I knew him. But he's an absolute brilliant
But there just seems
SDR
like a
guy.
lot of signals of opportunity we could be using if what you wanted to
Absolutely.
study propagation, because there's a lot of other people studying propagation too,
Right.
either off the ionosphere or off the ocean
Well,
surface.
Well, the funny part, another project that we were connected with from MIT Haystack, Frank Lind had a project he called ISIS, and that was a passive radar system using FM broadcast
Yeah.
as the signals. And
Yeah.
it was interesting. It was partly funded by DoD,
Yeah.
and he could talk about using it for ionospheric research, but you couldn't talk about what else. And I said, yeah, you could see planes.
Well, I wondered about that here since I live near a military airfield that has an air show every year, including the F-117A. And in the opposite direction, I have several strong digital TV transmitters that
Yeah.
possibilities have occurred to me.
Well, I had a period I was doing FM DXing, and I knew there was a very distinctive sound of FM station bouncing off of an airplane.
Oh, yeah. Oh, sure. But don't you think a digital signal will be even more useful?
Oh, yeah. I'm just saying that, they were using that signal of opportunity. It was the same as
Sure.
others where you have a receiver next to the station using it as reference, and then you can um, correlate that. Whatever modulation they have, you can cross correlate it and figure
Sure.
out where it's bouncing off of.
Well, I
That-
got thinking about this by looking at the F-117A at the air show and thinking, all those odd angles are because they don't have perfectly absorbing surfaces. They have to do other tricks.
Right.
That countermeasure only works against monostatic radars, right?
Yeah. The other thing I think what this also points out is that low frequencies, they probably aren't that stealth at.
Yeah.
The higher frequencies they can absorb, but you go down into the VHF and such, they're probably reflecting fairly well.
I
Yeah.
think-
Hence all those odd angles.
I think Matt Edis and what's his name? The guy who wrote the new radio stuff.
Yeah. Yeah. What was his
Had a
name?
video about doing this out in the desert, and they were like using I don't remember whether they were using like a TV station in Seattle to see uh, uh, planes in Nevada, or I don't know what
Oh,
it
yeah.
was.
Yeah, well, this is, like I say, had figured out how to do this using the RTL SDRs.
And there was recently some brouhaha about people doing it. It had gotten attention of somebody and some politician or something, and this was, they were gonna have to pass a law to stop people from doing passive radar.
They were smart that we realized
Like,
that what some ham can do on his computer, anybody could do. Come on.
yeah.
Like I'd like to say, look, I mean, if look what I'm able to do with a PC and an RX 888 or a couple RX2s. Only can imagine what the NSA must do with their budget.
Yeah, really.
Seriously.
Well,
It's not like I invented any new mathematics either, right?
maybe twice as much for 10,000 times as much budget.
Well, yeah, we are talking about the government. It's true.
But still, it must be fun.
I was always amused by Bob McGuire's stories about working in embassies around the world. And they don't even try to hide it. I mean, the first time I went to Singapore, like 1994 or something like that, and I was out for a walk and I turned the corner and there was the US Embassy and the roof was just covered in plaster with antennas. And I just cracked up laughing because they're not even subtle about it.
Yeah. Actually, one of the earliest electronics magazines I remember having had an article about the classic embassy bug, the
Yeah,
passive radiator embassy bug.
yeah. And you know who designed that, right? Theremin, the same guy who designed the musical instrument. Yeah, oh yeah, the same guy. Leo Theremin, right? Look it up.
Interesting.
It's not rocket science.
No. So when I hear all this crap about microwaves being used to attack Americans in embassies, I wonder, I mean, are they still doing this stuff? I mean,
Probably.
and why is it so hard to find? It's not like microwave receivers are hard to make.
Yeah, that's what bothers me about it.
Yeah, it doesn't make sense.
If you know anything about it, it's not hard to find it.
No, not at all.
But there are a lot of people who don't know.
Now, they may be getting sick because of all the RF, ambient RF and the environment from
Yeah.
kind of friendly.
If there's enough, I mean, from what we know about RF, it still has to be pretty strong before it does anything like that.
Yeah, I know, but it might be our own.
God knows it certainly hasn't affected us any.
I'm still amazed that when I fire up the microwave, my access point keeps working. Still amazing to me.
Well, I remember when it was an issue that they were radiating.
Yeah, but they can't be radiating much, not if my access.
No, they're not. No, they aren't now, but though there are, trying to think, where do I've run into microwaves interfering with something. Of course, the classic one nowadays is the interference to Green Bank,
Yeah.
where they discovered it was microwave. They were looking for
Oh,
little
wait a
green
minute.
men.
You're thinking about one in Australia.
No,
The large.
I think it was here at Green Bank.
No, there was
And-
definitely a case in Australia at the Parkes Radio Observatory where they were trying to track down a source, and it turned out to be pulses from microwave radar. I think when the microwave oven when the door was open, or something like
Yeah.
that.
Okay. Well,
Basically would allow
one of
there.
one of the telescopes, radio telescopes.
I mean, I would be surprised
yes,
if it would allow microwave ovens there.
What's that?
I'm surprised to even allow something like a microwave oven at a observatory.
Well, they're supposed to be shielded, but the problem is a lot of them allow you to open the door before the magnetron shuts off.
Yeah, well, I
And
wouldn't
that
assume.
was the pulse
Come
they
on,
were seeing.
nothing is shielded with at these signal levels.
Well, yeah, I mean, something's going to leak out, but clearly it wasn't leaking except when that door was opened while it was still running.
Right. And the problem with radio astronomy is you often don't know you're being interfered with until much later.
Right.
When you analyze the data. When I visit the Allen Telescope Array, I've realized, yeah, I mean, boy, all the things these guys have to do to just, I mean, there's no Wi-Fi, for example. You got to go find an Ethernet drop, just like in the old days, if you're going to read your mail. Stuff like that. And they're not even in a radio quiet zone. They have to make do with what they got. But I'm really coming to the conclusion that on HF especially, antenna gain doesn't mean anything anymore. It's all about noise level. That wasn't true before. It sure is true now.
Okay, I just looked it up. It was Parkes.
Yeah, I thought so.
But it was one of those.
I remember reading about
places.
this. Yeah. But like I said, I'm surprised they even allow microwave ovens in the first place. Considering
Yeah.
S is one of the frequencies they use. It's not far away. You know, the D spaceband is 2200 and microwave ovens are 2400. And they're kind of notoriously uncontrolled. I still like how, one of the biggest inventions of World War II is now used to cook hot dogs. And not much more.
Yeah, well, that's because they kept frying pigeons. Well, on that note.
Yeah.
I guess so.
I guess I'm feeling better. God, the flu sucks.
Yeah, really. Well, I know there's something else going around that my partner got and hung on for like 2 weeks. Well, for whatever reason, I seem to be immune to it because I didn't.
Yeah, well, I got it. And then my wife got it like 2 days later. So it wasn't just me. I thought it might have been because I have a weakened immune system, but no.
My wife and I have been so lucky. I think she's made something like, I was trying to think, 11 or 12 trips to Europe and back since the beginning of COVID.
Mm.
Really?
Yes, right through the middle of it. Her parents were failing all along that time. And And, you know, we're careful and we got every single jab you could, but neither of us ever has gotten really anything, mild colds.
Well, back then you were probably on empty airplanes.
No. She wasn't actually. I don't know, but she was just careful. But as a matter of fact, I think my father-in-law really kind of died of consequences of COVID.
Oh, geez.
Not a direct, but you know, he had it and he was failing anyway. And
So many people have. I've forgotten what the toll is up to now, but
oh, that's huge.
huge number.
But we've been healthier in the last few years than we've ever
I
been.
mean, you don't kill that many people without a war, usually, a big war. Of course, many people die in wars do die of disease, in fact.
Yeah. It's a complicated subject, really, once you
Yeah.
start looking at what and how people die, because they die of secondary causes so much within the context.
Flu,
Right.
right?
Yeah.
Flu certainly helped that one. World War I, excuse me.
Yep. Classic example.
Yeah.
Yeah. There's always something new crawling out of the woods.
Yeah. Well, in good news lately, I've been looking at renewable power production in California. My God, I mean, I think one day they hit as much as 145% of load was being produced with renewables.
Really?
Wow.
Yeah. And they're
Wow.
exporting a lot of it.
It's great. Is there a lot of solar installed?
Oh, huge amounts. I mean, grid scale solar alone hit, I think, about 17 gigawatts today.
Uh-huh.
Yeah, and
You
you
know,
have
like a gigawatt
there's a
is,
lot
right?
of wind power as well.
What are
Yeah,
people
yeah.
resident?
And batteries have really taken off too. I mean, that's been the biggest surprise over the last few years is how quickly batteries are being built. Let's see, right now it's about 7:30 local time, West Coast time. We're probably peaking out on batteries. Let's see what it is. I can go to the California ISO website. Oh, they just reorganized there. All right, how do I find a cute little graphs here?
They're just finishing up the installation on my rooftop stuff.
I need to replace my system. It's ancient. I'm not going to buy any more lead acid batteries. I'm certainly not. That's one thing I'm not going to do. Not anymore.
I've got some of these lithium, you know, larger lithium iron phosphate ones, but they're not part of my household supply. I may use them at a little cabin up in the north part of the state. I have that runs, you know, to run some of this kind of equipment.
Yeah.
If I can get the energy to go up there and install it.
See, even right now, renewables are 24%, probably because we've been having a lot of wind lately. 7.5 gigawatts out of a 31.5 gigawatt load. That's substantial, and that's, you know, the sun is almost set here, so there's certainly no solar anymore.
Well, it was going to take 50 years to install even a little bit.
Yeah, come on, where is the current demand? Looking for batteries here. I keep changing.
They break down. Is this the large batteries installed around Southern California or the?
Yeah, well, all around California, they have utility scale batteries. This is all before this is all utility scale, but the solar and the. Okay, yeah, right now they are discharging batteries at 6,269 megawatts. and they haven't reached the peak yet. Earlier
Uh-huh.
today, around noon, they were charging at almost 6 gigawatts. That's a lot of batteries.
Yeah,
Yeah. So all the people complain about, well, what happens if the sun doesn't shine? Well, there's an answer now.
yep.
Now I got a question. How long do those would those batteries keep the servers up?
Uh, well, how long do you need? Peaks don't last forever. It's why they're called peaks.
Right.
But is it all going to run Bitcoin mine?
Yes, Bitcoin mining.
Don't get me started on cryptocurrency. God,
What a waste.
I have another reason that I hate cryptocurrency. It's enabling ransomware.
Right.
Yeah,
And they've been going after healthcare networks. I mean, my own healthcare network, Scripps Health, got hit a couple of years ago, and oh man, what a disaster that was. I mean, the computer stuff was down for like over a month, and they still never really came clean on exactly what happened.
Yeah, and speaking of that, we still don't know exactly what happened to ARL.
Obviously some embarrassing hack they don't want to talk about, but I
Right.
guess you can read between the lines.
Well, it probably had some legal aspects to it
Oh, I'm sure it did.
that why they aren't talking.
But the legal stuff is even worse when it comes to healthcare because you have HIPAA involved.
Oh, I know it.
Right. I mean, consider that with, and Mike's not here to comment on this, but imagine if you've, even if you're a big healthcare network, even if you have full backups, well, suppose they made copies of all this stuff and they can threaten to release it. Okay. Your backups won't help you, right? It means you still get hit with a huge HIPAA violation,
Right.
you know?
yes.
So I wish Bitcoin and all the others would just die.
Yeah. Well, they're not currencies.
Of course not.
It's
Oh, it's
a
a
mistake
mechanism.
to call them currencies because you don't make money on currencies.
No,
Currencies are supposed to be stable.
right.
It's a pyramid scheme.
It's exactly what it is. Well, not only that, I mean, there's four use cases for cryptocurrency: extortion, money laundering, tax evasion, and black markets.
Yeah, really.
Seriously, I mean, is there another one other than speculation? Or
Nope.
I should say gambling. And you know, the Bitcoin enthusiasts I know get mad when I say that, but they don't really have an answer for it.
No, they don't. Anyway,
Anyway,
I think I'm going to QRT here.
fun guys.
Later.
Take care.